All right, so we're going to do a simple conservation of energy roller coaster problem. All right, so the question says that a 210 kilogram roller coaster car starts off at rest 150 meters above the lowest point of the ride. The car is then released and goes down the hill. What is the velocity at the lowest point? All right, so let's draw our roller coaster. Okay, so we know that we're starting off at 150 meters above the lowest point. So let's go ahead and mark off what we know here. So we have a height, we'll call this initial height, is 150 meters. And we'll say this is the lowest point here. And we want to know what the velocity is at this point. So we don't know this velocity. They also tell us the mass is 210 kilograms. So how do we find this velocity? If we start off up here in our car, we're also told that this car is starting from rest. And anytime you see from rest, what that means is the initial velocity is equal to 0 meters per second. And in a conservation of energy problem, that also means the initial kinetic energy is also 0 joules. Using conservation of energy, we can say that our initial energy, our total initial energy, has to equal our final energy. So we're starting off at the top at rest, so we have no kinetic energy, so we just have potential energy, and that's just going to be gravitational potential energy, mg times the initial height. So that's all of the initial energy, and that has to equal the final energy, which we know is going to be completely kinetic energy because our height is now 0. We're at the bottom, so mgh would be 0. And so our kinetic energy is going to be 1/2 mv squared. And we just want to solve for this velocity using this equation. The first thing we can notice is that we have the mass on both sides, and so we can just divide through by m and cancel those out. And that's just going to leave us then with g h1 equals 1/2 v final squared. So let's just multiply through by 2 and then take the square root to get that our velocity is then going to be square root of 2gh. So plugging in the values that we have, that's 2 times g, which is going to be 9.8 meters per second squared as always when we're on Earth, times 150 meters. And that gives us a final velocity of 54 meters per second.